All right, so 2-5. All right, so we're going to use the fundamental theorem of algebra. Doesn't that sound awfully official? No. Here it is, labeled right here for you. Oh, where's my highlighter? There we go. So here's what your fundamental theorem of algebra is. I'm not going to force you to memorize any of this, but you already know all of it, so it's nothing that you have to memorize. Here are your things that it says. Every polynomial with a power greater than 0, which means if it had a power of 0, wouldn't it be like y equals 5, right? There would be no x variable. Has at least one 0 in the complex number system. So remember that the complex number system is a plus bi. We just did that yesterday, or day before yesterday. 2 days before yesterday? See, I'm losing my mind. And doesn't this mean that in the complex number system you have real numbers, a real part, which is your a, and then the imaginary part, imaginary, just the bi. Told you, it's the end of the day. So any number that you can think of is going to be a complex number, isn't it? If I just said to you 5, that's a complex number, isn't it? It just doesn't have an imaginary part to it. I mean, we wouldn't normally call it a complex number, but there it would be. And then if I just had 3i, that's an imaginary number, but it's still considered a complex number. So the point of this is there's at least one 0 that's in the complex number system, either real or imaginary. Isn't that logical? All right. And so far, you've been finding zeros of things that have no imaginary zeros yet. Am I right? How do you know if there's an imaginary 0? Mm-hmm. Looking at a graph.
There's an I next to 0.
Nope. If there's an imaginary 0, then the graph doesn't actually touch the x-axis there. So let's say that we had a cubic. Couldn't you have a cubic that only crosses the x-axis once? You know how the cubes have like that S shape where they have a max and a min, right? So it is possible, if I drew that graph a specific way, that it would only cross the x-axis once, right? And the max or the min might not actually hit the x-axis. Does that make sense? And so that's where your imaginary comes into play, because it doesn't actually touch the x-axis, but if I have a cubic, how many zeros are there? 3. So that's what this one is saying. The power of the function tells you maximum number of zeros, and so that's your highest degree term. You need to pay attention to that, because that tells you how many zeros you're looking for, because now we're finding all of them, including the imaginary ones. And so if the last one is if you have a complex 0, meaning something that has an imaginary number to it, then the conjugate is also a 0. So that's kind of a handy thing to know. This one you didn't know. So for example, let's say that your 0, you know, we've been looking at zeros as being like 5 or -5 or 1, right? Let's say that your 0 turns out to be 3i. The conjugate of 3i is -3i. Complex zeros come in pairs, unlike real zeros. If I had 5, we didn't necessarily have -5 as a 0, did we? No. Sometimes, like one of your quiz questions yesterday, you had like a +1 and a -1, and then you had like a -3, right? Well, the -3 didn't come with a pair, did it? Nope. So, but these ones always will. So if I tell you that we have a quadratic, or I'm sorry, something to the 4th power, and I gave you one of the zeros as 3i, and I didn't tell you, bless you, the other one, you have to know that it's also 3i. If I give you a 0 that's 4 plus 6i, conjugate's 4 minus 6i. How would you write this 0 in factored form? Like its factor form? This is a 0 form. What's its factor form? If it were just 3, what would you have written it as a factor? X minus 3. So if it's 3i, what would you write? X minus 3i. And this one would be X plus 3i. Now these ones become a little bit more complicated when you have to write them in factored form. This would be X minus, and then you have to put all that in parentheses, 4 plus 6i. Then you have to distribute the negative and write what you have left. And this would be 4 minus, and then all of that in parentheses, 4 minus 6i. So we'll work on that a little bit. All right, so Example 1. We're going to find the zeros of a polynomial function. Yay. So we're going to list all the possible factors. So nothing's changed from what we did last week and partially this week. How do I figure out what my possible factors are? P over Q. Am I missing any terms? Yes, I am missing my x to the 4th term, right? So that's going to become important when we do synthetic division, right? So P over Q, what's my P? 8. So I have plus or minus 1, plus or minus 2, plus or minus 3, no, not 3, oops.
4.
Yeah, let's try 4. Plus or minus 8. And all over what's my Q? Plus or minus 1. So what are my possible factors? Put all of these over 1, right? So we have over here, plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. So we have a possibility of how many different factors? 8 of them, because there's 4 there and then double it, right? Now, you're not supposed to use your calculator to do this. Because we only had 8 shots in the dark, right? Oh, that's 8 synthetic divisions possible. All right, so I'm going to take one of these and start off with synthetic division, correct? What would you like to start with? 1. 1 would be now here's the deal though. Some of these can be double roots, can't they? Oh, that's going to be kind of hard to tell. That's why it's nice to cheat a little bit on your calculator. But I would always start low and work your way high. That doesn't mean that 8's not going to be a 0. And remember your upper and bound rules, that can kind of tell you, it doesn't mean it's a 0. It just means that when you find the alternating pluses and negatives or all positives or zeros, those are your upper and lower bounds, right? So we said 1. Let's start with 1. So I've got 1. I'm missing my x to the 4th, so 0. 1, 2, negative 12, and 8. So we're putting 1 in. So go through your division. Oh, looky there. Aren't you smart people? Did it work? Okay, so shot in the dark we got on the first try. It's possible that that's a double root though, isn't it? So one of my zeros is 1. Right? Now before we go on, I am going to show you what it looks like on the calculator. So let's go ahead and graph that in y equals. This is what my window looks like. Oh, I'm going to fix my window. Make sure your window's fixed. Alright, so x to the 5th plus x cubed plus 2x squared minus 12x plus 8. Huh. How many zeros should there be total? What's the highest degree term? 5, right? Well, it only touches the x-axis where? Twice, right? And when it sits on the x-axis like this, do you remember when your parabola would sit on the x-axis? Didn't you have a double root? Do you remember that from algebra 3, 4, and 1, 2? If your graph just touches, and we just found out that 1 was a root, right? So if it touches the x-axis like that and bounces right back off, it's going to be a double root. So I know that I have 2 1s, so we're going to do synthetic division again with another 1. And then what's this number? It looks like negative 2. So that's going to give us a total of how many roots? 3. How many are we missing? 2 of them. And doesn't that mean that I'm probably going to have 2 imaginary numbers? Don't imaginary numbers or complex numbers come in pairs? Does it make sense that I would have 2 that are missing? Okay, so we'll find those in a minute. So let's go ahead and do synthetic division again. I'm gonna put 1 in there again. And sure enough, what do you get? And notice I did not start synthetic division all over again because you're trying to break it down until you get down to a quadratic to where you can factor. So this was our step 1. We did step 2 again. So this 1 turns out to be a double root. Then what else did our calculator tell us we might want to try? Negative 2. So then we're going to do this again. And we're going to put negative 2 on the shelf. And did it work? Yep. So that means that negative 2 is a root. And because one of them's a double root, I have to come up with 2 more. So here's my quadratic. This is x squared. I have no x term, right? Because it's 0x. And then plus 4. So step 3, we're going to factor. X squared plus 4 equals 0. Get x squared by itself, so you have x squared equals negative 4. And then what do? Take the square root of both sides, and when you take the square root of a number, you have to do plus or minus. So square root of x squared is x equals plus or minus the square root of negative 4. Now we learned how to deal with that, right? The very first thing I want to do is what? Pull out the I. So plus or minus I square root of 4. Now what some of you did on your quiz was you wrote it as 4i. Did you actually take the square root? No. So that's kind of where you went wrong in that step. So I just pulled out the I. Then what's the square root of 4? 2. So we've got plus or minus 2i. And so isn't that our other root? Our other 2 roots. So now do we have 5 total? Yep. Now the things that you need to keep in mind, how many roots total do you have? Your complex roots come in pairs. So if you have one complex root, you have its conjugate as its pair, and 2i and negative 2i are conjugates. The real numbers without any imaginary part, they don't have to come in pairs. All right, the last thing that we're going to do. What? Oh, did I miss it? Sorry. Is that better? Oh, you might want to write off here to the side. These are your imaginary roots. Now some of you are going to like this next one, some of you are going to hate it. Joe, are you awake? You don't look awake. You might want to actually take notes on this stuff. All right, ready? All right, so this time you're finding the polynomial. That means you have to come up with the, x to the 5th plus 4x squared, whatever. So you have to find that polynomial given that these are your zeros. They're not going to give you all your zeros, though. They'll give you all your real zeros, but they're not going to give you all the imaginary zeros. So if I have zeros that are -1, -1, that means I had a double root. So if they have a double root, they're going to have to tell you that. Otherwise, how would you know? And then they give me 3i. What do you know about 3i? Yeah, so since it's imaginary, right, it's special, and then it comes with its own conjugate. What's the conjugate? -3i. So write yourself a note, complex zeros. Come in pairs. So since I have 4 zeros, what's my highest degree going to be? Yeah, x to the 4th, something x to the 4th. So f of x is equal to, write that as a factor. What's it going to be? X plus 1 times x plus 1 again, right? Then x minus 3i and x plus 3i. 100% of the time, your imaginary or your complex zeros that come in pairs will always have a special kind of factor pattern. What kind of factor pattern is that? The difference of two squares. So you should know how to multiply that. I mean, you could FOIL it out if you wanted to, and that's fine. But you should know that it multiplies as this squared minus this squared, right? So we get x squared minus 3i squared is 9i squared. And then this multiplies out. You can either FOIL it, or if you know what x plus 1 squared is, you can do that as well. So you might have to do 2 FOILings to get those.
You can just change the +9.
Yes, we're going to. Absolutely. And why are we changing it to +9?
I squared.
Yeah. The I squared means it's -1, right? So -1 times 9, it changes that to +9, and you absolutely positively want to change that before we finish multiplying. So I am going to change that. Now you're going to have to do a double distribution, or triple, however you want to look at it. We're going to multiply the x squared to everything in here, right? And so we get, I'm going to put my work over here because I ran out of room. So x squared times x squared, there's our x to the 4th. X squared times 9, 9x squared. Then for your second multiplication, we're going to take 2x times x squared and also times 9. So 2x times x squared is 2x to the 2, plus 2x cubed. I don't know why my mouth is not working. And then 2x times 9 is plus 18x. And then your last multiplication is 1 to all of these. So then I got 1 times x squared. Because that's a like term to this one, I'm going to put a plus x squared here. And then 1 times 9 is 9. And then add them all together. So x to the 4th. I like to put it in descending order, so I'm putting the plus 2x cubed next. And then plus 10x squared. Plus 18x. And then plus 9. So isn't that what f of x is? Now, the only other thing I'm going to tell you is this, and so flip this over. This is an extra gift from me to you. If I gave you 4 minus 6i as a 0, what is its conjugate? 4 plus 6i. Then if we were to write the polynomial associated with this, you have to write it as its factor form. So you have to write it and use brackets as x minus, and then in parentheses, I guess I don't need that parentheses, x minus the 4 minus 6i times x minus, right, the 4 plus 6i. Because technically, don't we always change the sign? If I had a -1, wouldn't I write it as x minus a -1, and that's how we get a +1? Or if I have a +1, x minus 1 gets me that -1. So using the minus here, we'll change all these signs. So we have to do plus, negative, plus, plus, negative, negative. And so what I actually have is x minus 4, but a plus 6i, and then x minus 4, and then minus 6i. So then I would multiply those together. I'm not going to go any further, but that's what you have to do for the complex zeros rather than the pure imaginary zeros. Yes.
Why wouldn't the x be negative?
Because x is negative, never negative. If I had 1 or -1, right? Wouldn't we write it as x minus 1? right, for this one, x minus 1? And wouldn't this one technically be x minus a negative 1?
Yeah.
Doesn't it become a positive 1?
Yeah.
So the x is never negative. What we do is we change the sign of the 0 and put it into the binomial, right? So that's all I'm doing here is changing the sign of this. It's just a more complicated thing. So both of them change signs. Okay, any other questions? All right.